We do have a couple of application problems to help us see how we ever would use literal equations. If Portalis reaches 105 degrees Fahrenheit or higher, what are the equivalent temperatures in degrees Celsius? So we can use the formula from example 4 that we just were working on earlier, and that was C, or Celsius degrees, are equal to 5/9 times Fahrenheit degrees minus 32. So what were we actually given in our scenario? 105 degrees Fahrenheit. So that's going to substitute for Fahrenheit in the formula. C now equals 5/9 times 105 minus 32. Now don't forget about the order of operations. We need to use the order of operations to finish this problem. So we would start inside parentheses with 105 minus 32. We're going to have 73. So if it helps you, you could write that as 73 over 1. So the Celsius temperature, 5 times 73 divided by 9 times 1. So 5 times 73, 15, carry 135 and 1 more makes 365 divided by 9. And we're going to have a repeating decimal here. So we know that 105 degrees Fahrenheit is about 40.5 degrees Celsius. In another situation, it says when the wind chill makes it feel like -3 degrees Celsius in Chicago near the lake, what is the equivalent temperature in degrees Fahrenheit? So now we're going to use our formula that was rearranged for Fahrenheit because our input value now is in Celsius. So instead of C, we're using -3. The Fahrenheit temperature would be 9/5 multiplied by -3, and then we will add 32. So the order of operations tells us to do this multiplication first. Fahrenheit now would equal 9 times -3 would be -27 divided by 5, and then add 32. So you could use your calculator and take -27 and divide that by 5. The last step, add 32, and your calculator will perform the order of operations for you. Just don't forget that the 27 is a negative number. And our answer will be in degrees Fahrenheit. You should get about 26.6 degrees Fahrenheit for that answer. The last few examples deal with calories and grams of carbohydrates, fats, and proteins. So the calorie count C of a serving of food can be computed based on its composition of carbohydrate, fat, and protein. So here is the given formula. And it tells you that H is the number of grams of carbohydrate per serving, F is the number of grams of F is the number of grams of fat per serving, and P is the number of grams of protein per serving. So we have a serving of cashews that contain 14 grams of fat, so F must be worth 14. 7 grams of carbs, so H is worth 7, and 6 grams of protein, so P must be worth 6. So what haven't we been told? We know F, H, P. We don't know the calories. But if we substitute these values into our literal equation, or our formula, we should be able to compute the calories. So the calories are equal to 4 times the carbohydrates, which is 7, plus 9 times the grams of fat, which is 14, plus 4 times the grams of protein, which is 6. So we end up with 28 added to, how much? 36, 126, add 24. So the calories would be 28 plus 126 plus 24, and that's about 178 calories for that serving of cashews. We're going to use the same formula, but this time we're given different information. A serving of raisins contains 130 calories. So this time we're given the calories. C equals 130. 31 grams of carbs. So H is 31. And it says raisins are a fat-free food. So that means fat would be 0 grams. So that's important to know. The question is how much protein is provided by this serving of raisins. So if we are not given a value for P, then we need to keep the variable. Let's substitute what we were given then. Calories are 130. 4 times the carbs, so 4 times 31. 9 times fat, that's 9 times 0, added to 4 times the protein. And protein we don't know, so that's 4 times P. If we simplify this a bit, we'd have 4 times 31, and that's 124. 9 times 0 would be 0, so we don't need to write that. And finally, 4 times P is 4P. Now there's no need to keep writing the parenthesis. We know that 4P also implies multiplication. So notice that 2 of the terms are constant terms and only 1 of the terms is a variable. So 4P is going to remain where it is, and we somehow need to move 124. So the subtraction property of equality is going to help us out here. Remember, that's the same as adding a negative number. So 130 minus 124 gives us 6 equals 4P. In order to isolate P, we need to eliminate multiplication of 4. Division of 4 would be the opposite. So now 6/4, we can reduce that, right? Both of these numbers are divisible by 2. So 6 divided by 2, slow down, be careful on that one, is 3. And 4 divided by 2 is 2. Now, if you leave the answer as 3/2, remember it is in grams, so you might find it more useful to take 3 divided by 2 to get P, or protein, equals 1.5 grams of protein. And our last example today, just to show you another format, how answers or a problem might be presented to you, and that's in table format. But we're still given the value of some of the variables. We're using the same literal equation. Carbohydrates are 21 grams for yogurt. So what we're looking for then, carbohydrates here, we're going to substitute 21 grams for H. Protein, 5 grams, so that is actually telling us what to substitute for P. And calories are 120, so we know the calories, or C, will be substituted with 120. So I have 120 equals 4 times 21 plus 9 times F. Notice we were not given F, so we need to keep that variable. Last, we have addition of 4 times protein, and that was 5 grams. So 120 now equals 84 plus 9F plus 20. So we actually do have some like terms to combine this time on the right-hand side of the equation. 120 would equal 84 plus 20. And 84 plus 20 is going to make 104 plus our 9 times F. So I'll subtract 104 from each side. 120 take away 104, and that's going to leave us 16 equals 9F. And finally, you probably realize you're going to have to divide by 9 here. So if we take this answer of 16/9, we want to take 16 and divide it by 9, and that will give us our grams of fat. So 1.8 grams is how much fat is in this serving of yogurt.